Guys, today I wanted to show you a new piece of the coverall, and it's a piece of hardware that's been incorporated into the design. And of course, as usual, it's a prototype and we can make changes and so on, but this is a new piece and it's quite an important one. I will step back there towards the camera and use a laser pointer to show you a couple of things, and then I'll move the camera closer in so that you can see it better. The lighting is weird, but I don't have time to set everything up so like a light studio, but I think you'll get the idea. So basically you can see what this is this big unit here, and I will here, let me step back and I'll show you what it is. Okay, you know the suit coverall already, and these ports are for letting in breathing gas and so on, and those are going to be rearranged a little bit as we tailor it specifically for the CS capsule, and also a different one for the balloon flights. But basically, right now, what's been added is down here in the leg a 5-minute oxygen supply. This is a bailout bottle. High pressure 3000 psi tank, and it contains 5 minutes of breathing oxygen 100%. You can see that it routes up here. The hoses route out, the two black ones. One goes up into this pocket, and another one comes up into this, what I'll call now a hand controller. I'll come back to that in just a moment. So, high pressure gas down here, you've disconnected, let's say, from ship oxygen, you're bailing out, and you've got this high pressure hose goes to this setup, and this high pressure hose also goes to this hand controller. By the way, both of them route to this hose, which goes up into the helmet, and this is a breathing gas hose. So your breathing gas is coming from the tank down here, up through these either of these two hoses, and then up into the helmet. Now I'll come in a little bit closer and show you exactly what's going on with that. Okay. As that breathing gas comes up out of the tank down here, let's start with this piece. Right now it's hanging on the side, or hanging on the suit, just to basically so I can start working with where this thing is actually going to be positioned, maybe in the center of the chest, I'm not sure. But the point is, what is this thing? Well, this thing, that's a protective cover. And what you see here is that the breathing gas that I was just mentioning, that comes up through that black hose, lights a little bit better like that perhaps, the breathing gas that comes up through this black hose enters this valve. This is a CRU-79P. It's a breathing gas valve for high altitude aviation. It's for when people bail out. And it's just like a scuba regulator. It's a demand regulator. And it's like scuba. You take a breath and it releases, it opens, and you get a breath of oxygen. You stop breathing and it doesn't continue to flow oxygen into your helmet, so it's conservative rather than having a continuous flow of oxygen. So just like a scuba regulator, but it's built for high altitude aviation. These are about $150. They are highly durable. They are rated for very low temperatures. I've read a test report like 100 below 0 Fahrenheit, and high altitude. It's rated to 50,000 feet, so you can be happy with it up to 50, and of course it's over-engineered, so it can go a little bit above that as well. Okay, high pressure oxygen enters there at actually about 80 psi, not very high oxygen. A valve downstream actually reduces the 3000 psi coming inside the tank down to about 80, which reaches this valve. Then it goes up into this manifold, which is basically just a casing. It has two ins and one out. You take a breath and the valve opens, and breathing oxygen goes up the hose to your helmet. No problem. Let's say that fails, however. I'm not flying with anything that doesn't have a backup, and in this case it's a manual backup, and that's what this device is here. This is a hand controller that will deliver, if you squeeze this button, it opens a valve. And it's also getting breathing gas directly from that high pressure tank that I mentioned before, from here. It's getting breathing gas from there. You squeeze this valve and you get a puff of gas, breathing gas. It comes up through this separate hose, right? You've decided, okay, I'm using manual because this one has stopped functioning. Now there's no way that you can run out of breathing gas or be prevented from breathing gas, because all you do is press this button and you get a puff of gas. And I've been working with this. It is possible to coordinate your movements and so on, such that a hand controller like this, it's not great, but hey, it's better than having nothing. There's a loop here to hold this onto the glove. Of course, that'll be bigger and improved, and it'll be metal instead of plastic fixtures, all of that, but as you know, proof of concept. The whole thing sits in this sort of backing. There's a big piece of heavy rubber here to give it some protection, and this cover basically covers it and prevents, it's pretty durable, but it prevents things knocking on it from dislodging or breaking anything. And that's pretty much it right now. I just wanted to show you that that's a hand controller and a breathing regulator for bailout scenario. And you can imagine that all of these systems have to be rebuilt, in particular from the perspective of low temperatures and 100% oxygen. Low temperature because we're going to 100 below or 70 below zero at 50,000 feet, somewhere on that order. And also they need to be all serviced for 100% oxygen, and that just is a rating such that there's no grease in the system. One drop of grease and you get a fire with 100% oxygen. That's pretty much it. I'll zoom in a little bit and you can see. There's that CRU 79P unit, breathing gas regulator. Nice little unit. And so this is all the bailout system. I'll back off here and see from a bit further back again. This is all for the bailout system. So what do you breathe? That's what I call bailout oxygen. What do you do in case of, or when you're flying normally? When you're flying normally, you use, instead of bailout oxygen, you use ship oxygen. And that will be another device just like this. This can all get considerably smaller, I believe. As I'm working on it, I can make that a little bit smaller. But another device identical to this, but smaller, over here next to it, and that's your ship oxygen supply. It also then gives you, so when you're flying, you're breathing off ship oxygen using a completely separate regulator, or if that regulator were to fail, a completely separate hand controller. And I think I did do a video a couple of weeks back, I can show it to you on YouTube, where there are controls for using manual delivery of gas. You can press buttons with your feet. They're just simple mechanical levers, or you can pull levers with your hands. And this gives a way you can continue to do things with your hands, and you just press with your foot to get a puff of gas. And there are 4 different ways to get gas that way. That's only, though, if the automatic demand regulator fails. That whole separate system, ship oxygen system, separate from bailout oxygen system, will be will be on a quick disconnect. And so if you need to bail, there'll be one motion, a quick disconnect, takes you off of ship oxygen. Now you're on bailout oxygen, and down you go. Okay, so I built the prototype bailout oxygen system, and there it is. So that's what I wanted to show you today. Have a good one.